Yeah, so my name is Martin von Zweigbergk. I expected my speaker notes to be here somewhere. But yeah, I work for on source control at Google, and I'm going to talk about a project I've been working on for almost 3 years. It's a Git-Compatible VCS called Jujutsu. And in case you're wondering, the name has nothing to do with Jujutsu Kaisen, the anime. It's called Jujutsu just because the binary is called JJ, and the binary is called JJ because it's easy to type. Oh, okay. Now, there it is. So here's an overview of the presentation. First, I'm going to give you some background about me and about the history of source control at Google. Then I'm going to go through the workflows and architecture of JJ. And then at the end, I'll explain what's next for the open source project and the integration at Google. So background about me, after graduating, I worked for Ericsson for about 7 years. And while there, I think it's fair to say I drove the migration to Git there from ClearCase. And I cleaned up some Git rebase scripts in my spare time. And then I joined Google and worked on a compensation app. And for the last 8 years, I've worked on Fig, which is a project to integrate Mercurial as a client for our in-house monorepo. So for context, let me tell you a bit about the history of version control at Google. So a long time ago, we supposedly started with CVS. Then we switched to Perforce. And after a while, Perforce wasn't able to handle the repository anymore because it got too large. So we wrote our own VCS called Piper. But the working copy was still too big, so we created a virtual file system called Sitsi on top of Piper. And that's what almost every user at Google uses now. People were still missing the DVCS workflows that they were used to from outside Google, so we added Mercurial on top of that. And as I said, that's what I've been working on for the last 8 years. And also, in case you didn't know, our monorepo at Google is extremely large and has like all the source code at Google. And you can watch this talk by Rachel Potvin from @Scale if you're curious. So generally, people really like Fig, but there are still some major problems we're having. Probably the biggest one is performance, and that's partly because of Python. Python is slow, and partly because of eager data structures that don't scale to the size of the repo. Another problem is with consistency. We're seeing write traces because Mercurial is not designed for distributed storage, so we get corruption when we store it on top of our distributed file system. And another pain has been integration because we're calling Mercurial, the Mercurial CLI, and parsing the outputs, which is not fun. So a few years ago, we started talking about what we would want from a next-gen VCS. And one of the ideas that came up there was to automatically commit, or to make a commit from every save from your editor. And I got really excited by that idea and started JJ to experiment with it. And then I worked on it as my 20% project for about 2 years. And this spring, we decided to invest more, so now it's my 100% project. Next. So you may be wondering why I didn't decide to just add these features to Git, but as I said, I want to experiment with a different UX, so I think that would end up being a completely separate set of commands inside of Git, and that would be really ugly and wouldn't and shouldn't get accepted upstream. And also, I wanted to be able to integrate into Google's ecosystem, and we had already decided with Fig that against using Git there because of the problems with integrating it with our ecosystem at Google. And one of the problems is that there are multiple implementations of Git that read from the file system, so we would have to add any new features in at least 2 or 3 places. Okay, so let's take a look at the workflows. So the first feature is anonymous branches, which is something I copied from Mercurial. So instead of this Git's scary detached head workflow or state, JJ keeps track of all your commits without you having to name them. So that means they show up in log outputs, and they will not be garbage collected. So it may seem like you would get a very cluttered log output very quickly, but whenever you rewrite the commit, so if you amend it or rebase it, for example, the old version gets hidden, and you can also manually hide commits with JJ abandon. And so one of the first things you'll notice if you start using JJ is that the working copy is an actual commit that gets automatically committed. And it shows up in the log outputs with an @ symbol. And whenever you make any changes in the working copy and run any JJ command after that, it will get automatically amended into that commit. You can use the JJ checkout command, and that actually creates a new commit on top of the commit you specify to store your working copy changes in. And if you instead wanted to resume editing an existing commit, you can use JJ edit. So this has some very interesting consequences. One important one is the working copy will never be dirty. So if you check out a different commit or rebase or something, it will never tell you that you have unstaged changes. You get automatic backup because every command you run creates an automatic backup for you. It makes stash unnecessary because your working copy commit is effectively a stash. It also makes commits unnecessary because it's already committed whenever you run a command. Your working copy is committed. So. And you can, if you want to set the description commit message, you can run JJ describe to do that at any time. We get a more consistent CLI because the @ commit, the working copy commit, behaves just like any other commit. So there are no special flags to act on the working copy. And for example, JD restore can restore files between any 2 commits. It defaults to restoring from the parent of the working copy and into the working copy, just like Git restore does, I think. But you can pass any 2 commits. And also, uncommitted changes stay in place, so they don't move around with you like they do with Git checkouts. So another one of JD's distinguishing features is first-class conflicts. So if you look at the screenshot there, we merged the working copy with some other commits from another branch, and that succeeds. even though there are conflicts, and we can see in the log output afterwards that there are conflicts in the working copy. And so as you see, the working copy commit there with the @ is a merge commit with conflicts. So these conflicts are recorded in the commit as in a structured way, so they're not just conflict markers stored in a file. And this design leads to even more magic. Maybe obvious one is that you can delay resolving conflicts until you're ready, until you feel like it. So if in this case, when we had this conflict, we can just check out another commit and deal with the conflicts later if we want to. And you can collaborate on conflict resolutions. You can resolve some of the conflicts in these files and leave the rest for your coworker, for example. Maybe less obvious is that rebase never fails. So, and same, I mean, we saw that here that merge doesn't fail. Same thing is true for rebase or all the other similar commands, which makes continue and abort and for rebase and cherry pick and all those similar commands unnecessary. We also get a more consistent conflict resolution flow. You don't need to remember which command created your conflicts. You just check out the command commit with conflicts and resolve the conflicts in the working copy, and then squash that conflict resolution into the parent that had conflicts. Or as in the screenshot here, we were already editing that commit, so we just resolve the conflict in the working copy, and it's gone from the log output. Yeah, remember, so now in the working copy here, in the second screenshot, the conflict has been resolved. So in the working copy, in the merge commit there in the working copy, that working copy resolves the conflict, right? So we're going to come back to that in the next slide. And a very important feature that took me a year to realize was possible is that because rebase always succeeds, we can always rebase all descendants. So if you check out a commit in the middle of a stack and amend in some changes, JJ will always rebase all the descendants on top, so you will not have to do that yourself, and it moves the branches over and so on. Yes, so you can we can actually even rebase conflicts and conflict resolutions. I don't have time to explain how that works, but it does. So in the top screenshot here, this is continuation from the previous slide. We rebased one side of the merge from conflicting change 2 there, and its descendants onto conflicting change 1. And of course, we get the same conflict as we had in the merge commit before, and that stays in the non-conflicting change. But then in the working copy, because we had the conflict resolution in the working copy, which was a merge commit before, that resolution gets rebased over and it stays in the working copy, so we don't have a conflict in the working copy here. Then the second screenshot, we ran JJ move to that commit with the first commit with the conflict, and that command is a bit like the auto squash that someone talked about earlier today, but much more generic. It can move a change from any commit into any other commit. So in this case, we're moving the changes from the working copy. That's the default. That's why there's no dash from. Move it from the working copy and into the conflict, the first commit with the conflict, and then the conflict is gone from the entire stack, and the working copy is, in this case, becomes empty. We can also rebase merges correctly by rebasing the diff compared to the auto merge parents. onto the new auto-merge parents. And that's actually how JD treats all diffs or changes in commits, not just when rebasing, so also when you diff a merge commit, it's going to auto-merge the parents, just like the remerge diff I think Elijah talked about before. And the last feature I was going to talk about is the what I call the operation log. So you can think of it as the entire repo being under source control. And by the entire repo, I mean refs, anonymous heads, and the working copies position in each work tree. So it's kind of like Git's ref logs, but they're across all the refs at once. And there's some extra metadata as well. So in the top screenshot there, you can see their username and host name and time of the operation. And as you can imagine, having these snapshots of the repository at different points in time lets us go back and look at the repository from a previous snapshot. So in the middle screenshot there, we run JD status at a particular operation, and that shows like just before we had set the description on the commit. So we see that the working copy commit has no description, but it has a modified file because it was from that point in time. And you can run this with any command, not just status. You can run log or diff or anything. And of course, this is very useful when you're trying to figure out how a repository got into a certain state, especially if it's not your own repository, so you don't remember what happened. And the last screenshot there shows how we restored the entire repo to an earlier state before the file was even added in this case. So that's the second operation from the bottom when we had just created the repository. So the working copy is empty and there's no description. And restoring back to an earlier state like that is very useful when you have made a mistake, but JD actually even lets you undo just a single operation without undoing all the later operations. So that works kind of like Git revert does, but instead of acting on the files in the commit, it acts on the refs in an operation. So the screenshots here show how we undo an operation, the second to last operation there that abandoned the commit. So we undo that operation and it becomes visible again. And the operation log also gives us safe concurrency, even if you have run commands on repositories on different machines and sync them via Dropbox, for example. You can get conflicts, of course, but you will not lose data or get corruption. And then in those cases, if you sync two operations via Dropbox, you'll see a merge in this operation log output. We also get a simpler programming model because transactions never fail. When you start a command, the repository is loaded at the current, the latest operation, and any changes that happen concurrently will not be seen by that command. And then when the command is done, it commits that transaction as a new operation, which gets recorded and can't fail, just like writing a commit can't fail. And this is actually why I developed the operation log for the simpler programming model, and then the undo and time travel stuff is just an accident. Okay, so that's all about features and workflows. Let's take a look at the architecture. So JD is written as Rust. It's written as a library to be easy to reuse. The CLI is the only current user of that library, but the goal is to be able to use it in a server or a CLI or a GUI or an IDE, for example. And I hope also by making it a library, we reduce the temptation to rewrite and have the same problem as Git. And because I wanted JD to be able to integrate with the ecosystem at Google, I tried to make it easy to replace different modules of it. And so, for example, it comes with 2 different commit storage backends by default. One is the Git backend that stores commits as Git commits. And the other one is just a very simple custom one, but it should be possible to write one that stores commits in the cloud, for example. And same thing with the working copy. It's, of course, stored on local disk normally, but the goal is to be able to replace that with an implementation that writes the working copy to a VFS, for example. Integrates with a smarter VFS by not actually writing all the files. And also, to be able to use it at Google, it needs to be scalable to very, very large repositories, which means we can't have any operations that need all the ancestors, for example, of a commit. So to achieve that, we achieved that mostly by laziness, not fetching objects that we don't need. So try to be careful when designing algorithms to not scale to the size of the repository or the size of a tree unless necessary. So another important design decision was to perform operations in the repository first, not in the working copy. So when all operations are at like write commits and update references to point to those commits, and then only afterwards, after transaction commits actually, is the working copy updated to match that state, the new state, if the working copy even changed by the operation. It helps here that the working copy is a commit, because then even when you're running a command that updates the working copy, it's the same thing. You just commit that transaction that modifies the working copy commit, and then update the working copy afterwards. We get a simpler programming model because we don't have to. We always create commits, whatever commit we need, and we don't need to worry about what's in the working copy. So same thing as Elijah was talking about, I think, with merge ort. And this makes it much faster by not touching the working copy unnecessarily. And also helps with the laziness because you don't need to fetch objects from the backend, which might be from a server, just in order to update the working copy and then update it back later, for example. And as I said, JD is Git compatible, and you can start using it on the same, independently of others who use the same Git project. So, and this compatibility happens at a few different levels. At the lowest level, there's the commit storage. So there's, as I said, there's one backend, commit storage backend, that stores commits in a backend Git repository. So that reads commits from the Git the backend Git repository, the object store, and converts it into the in-memory representation that JJ expects. And there's also functionality for importing Git refs into JJ and exporting refs to Git, and for like interacting with Git remotes. And of course, these commands only work when the backend is the Git backend, not with the custom backend. And of course, since I worked on Mercurial for many, many years, there are many good things I want to replicate, such as the simple, clean UX with, for example, it's rev sets language for selecting revisions, and the simpler workflows without the staging area. So I copied those. Mercurial's history rewriting support is also pretty good with HD split and fold, for example, for splitting and squashing commits, and HD rebase, which rebases a whole tree of commits, not just a linear branch or a single branch at least. So I copied those things as well. Then Mercurial is very customizable, mostly thanks to being written in Python. So that, since JJ is written in Rust, we can't just copy that, but you can't use monkey patching in the same way. But I hope the modular design I talked about earlier at least helps there, but it still have a long way to go to be as customizable as Mercurial. Okay, so let's take a look at our plans for the project, the open source project, and our integrations at Google. So remember, this project has been my 20% project for most of its lifetime, so there's a lot of features and functionality missing. Like, for example, GC and repacking is not implemented, so we need to implement that for both commits and operations. For backends that lazily fetch objects over the network, to make that perform okay, we need to do some batch prefetching and caching. There is no support for copies or renames, so we have to decide if we want to track them like Mercurial or BitKeeper does, for example, or if we want to detect them like Git does. Happy to hear suggestions. And just lots of other features are missing. Like, this particular one I actually got a pull request for a few days ago. So, but still, like Git blame, for example, is not there. We need to make it easier to replace different components. Like, for example, adding a custom command or adding a custom backend without while using the API and not having to patch the source code. Language bindings, again, want to avoid rewrites, so hope people can use the API instead. So we want to make that as easy as possible in different languages. Security hardening, and the custom backend, the non-Git backend, has very little support. Like, there is no support for push and pull, for example. So that would need to be done at some point. But the Git backend is just what I would recommend to everyone for many, many years ahead anyway. So, and of course, contributions are very welcome. The URL for the project is there. We don't want this to be just Google running the project. And yeah, as I said, this is now my full-time project at Google, and the goal of that project is to improve the internal development ecosystem. There are two big main parts of this project. One is to replace Mercurial by JJ internally. The other part is to move the commit storage and repository storage out of the file system and into the cloud. So we're hoping to create like a single huge commit graph with all the commits from all Google developers in just one graph. And by having the repositories available in the cloud, you should be able to access them from anywhere, and from like a cloud IDE, for example, or review tool should be able to access your repository and modify it. So, and this diagram here shows how we're planning to accomplish that. So most of this is the same as on a previous slide. I've added some new systems and integrations with in red. One of the first things we're going to have to do is to replace the commit graph, which is called commit index there in the diagram, because it currently assumes that all ancestors are available, which of course doesn't scale to the size of our monorepo. So that's we're going to have to rewrite to make that lazy. I'm probably going to use something called segmented changelog that our friends at Meta developed for their Mercurial-based VCS. Then we're going to add new backends for the internal cloud-based storage of commits and operation logs. Well, operation logs are basically repositories. And we'll add a custom working copy implementation for our VFS. So we're hoping to not use sparse checkouts. So instead, our VFS is, we can just tell the VFS which commit to check out, basically, and like a few files on top. And we'll add we'll add a bunch of commands probably for integrating with our internal integration with our existing reviews and like starting reviews or merging into mainline and stuff like that. And then we're going to add a server on top of this that will be used by the Cloud IDE and review tool. Yeah, that was all I had. So thanks for listening. If you have any questions, you can find a link to Discord chat, for example, from the repository page, GitHub page. And feel free to email me at martinvonc@google.com. Thank you.